Our next guest on stage is Dimitri Jonghe from Ocean Protocol. Welcome, Dimi. Round of applause. Woo! So Dimi is co-founder and head of product and research at Ocean Protocol, and we talked, of course, about, okay, it would be so interesting to have Ocean because of your experience with token launches and the entire journey from protocol pre-launch to in early 2018, I guess, until now. And there you go, engineering notes on launching the Ocean network and tokens and all the stuff we didn't think of. It's yours.
Hi everyone. Is this on? Or do I need to press a button?
Yeah, thanks.
Hi. Hey. Yeah, thanks for the intro. I think what I want to share for today is a bit more like really practical engineering, like close to DevOps. So we had always these big, gigantic ideas on what to build for, but then when you actually start practically doing it, turns out you forgot, or you just couldn't think of a lot of stuff. It's mostly about, yeah, you just have to have a good plan in order to launch a network, deploy your contracts, make sure they are upgradable, make sure that you leave some room for error and margin, and that you deploy this in the right steps. So I just wanted to share some of these notes because I think it's just practical. It might, hopefully, it saves some of you guys 1 or 2 days of your current plans for deployment. And if that's the case, then I think that I've been successful. Otherwise, if I add more time to your stuff, then yeah, I failed. But here we go. Right. So first, you kind of want to gather all the capabilities that you want your network and protocol to encompass. So I'll give you a bit of a rundown very quickly on what Ocean's supposed to do, what it actually does. We sometimes refer to this, to Ocean Protocol as either a public intelligence network, meaning that there's a supply chain of services, data services connected to each other, and they try to solve problems. And Ocean is built in a way that you have fine-grained permission structures between all those services, and you have attribution along those services as well. So if you do something successful, this entire supply chain gets rewarded. So we could call it an InterService Network. We're not saying that, well, you have to pick this compute, this cloud or this. No, it's very heterogeneous. There's a lot of service providers here. There are Web 2 and Web 3 service providers. And we've tried to find a way to create full supply chains of services that have the capability to solve interesting problems, necessary problems. And everybody within the supply chain, every service, can have an attribution aspect and a governance aspect to it. So parts that we're thinking of is, well, can you create machine learning communities? Because for me, a token network is still all about coordination between agents, and those agents can be human or non-human. So what we're trying to see is that, well, if somebody is capable to solve one problem, for example, we have something going on to predict lung capacity from X-rays, so there's a lot of object recognition and anomaly detection going on there. If this is a successful project, can we create something that's called X-ray Net? And that actually attracts a community, has an incentive around it for people to contribute to that, such that you create stronger healthcare capabilities. You can also think about autonomous vehicles, you can think about preservation of natural resources. It all needs to have like a sort of community with an identity and an incentive around that. And maybe if you have a solution that works in one domain, maybe that can signal itself forward to other domains. So here you have not problems looking for data, but data knows it can solve some specific set of problems and signals itself forward to new problems. I think that's very interesting. Now, a lot of these services and data science and data engineering flows, they're currently living in Web 2 real estate. And then we're saying they're living in the cloud, they have toolkits that aren't necessarily Web 3 compliant. And when we're talking about data, we're often talking about privacy, but we forget that we're actually talking about information exchange. So we try to find the useful protocols for people to extract information from a set of data or machine learning algorithms. So you enter into kind of a protocol negotiation where, for example, some data scientist wants to deploy an algorithm on a data set, but the data set owner doesn't want to have any data escape. So the protocol could go like, hey, can I run this algorithm? Or can I pull your data into my algorithm? The data owner says, no, it's too private. I only allow algorithms to come to my secure private zone and there deploy an algorithm of these types of structures. For example, I only want to have algorithms that are provably secure from a data escape point of view. So this type of negotiation needs to take place between two actors, the one owning the data and the one wants to learn from that data. And that's happening in Ocean through something we call service execution agreements. And that's our access policy. And it goes a bit like this. These are instances on smart contracts. They're basically smart contracts negotiating conditional access. So it's modular. You can compose it out of cryptographic conditions, saying that, for example, hey, if you want to access this service, you have to prove that your public key comes from a set of trusted public keys, for example. You need to deposit this amount of tokens for security bounds. You need to deliver a proof of computation or a proof of retrievability for you to successfully prove that you actually delivered the service. Basically, this entire negotiation, we try to put it conditionally into smart contracts, deploy those on chain, have a cryptographic messaging back and forth between the actors, and then rewards are being dispensed in the end. So a little bit of the layout there. It's very close to what people would call service level agreements, but we moved that concept into smart contracts, and it's a very core engine within our protocol. And then, of course, we want to incentivize behavior inside of the network. So we have a network reward function, which is quite flexible to program and can steer and be governed over time. Currently, we're promoting people to provide something that's called commons.oceanprotocol.com. So there we just want to have free data sets. People hosting and providing free data sets are eligible to get rewards initially, because we want to get rid of something we call the empty network problem. But once more and more data sets come in, you kind of want to have high quality data sets, and then we can shift our network reward function to curation functions. And if we want to have more provable services, and then we could shift it towards proof of execution, proof of service providers. So creating this reward chest is something that we think, well, it's interesting and useful, but also needs to be dynamic. So we have to take that into account when we're going to design for this, that there is a governance layer need to be attached to it and needs to be programmed over time. Another interesting thing that we have is when, well, we have the ability to inject basically liquid ownership onto these services. So we use things like bonding curves that can attach to these policies. And it's a bit like a refungible token, right? So each service agreement you can think of, well, that's kind of an NFT, and then we make it liquid in the ownership structure by attaching the owner to a bonding curve. So this also could then say that people that signal forward that this is an interesting service, they get an early mover advantage, and that can then be rewarded through this network reward function. These are all things that either we have done or we're planning to do. And the thing that we need to solve now is the problem, how are we going to set up our deployment plan to make sure that all these promises can actualize with us, without us like fixing ourselves in a specific direction that we can't get rid of. So there's a few things. You want to first simplify the problem, right? There's a lot of capabilities you want to do, so we need to simplify it a bit. So one way you can do it is you can say, well, we're going to split it up in protocol layers. So at the bottom we have service providers. They are connected through a decentralized access control token. I'll talk about that a little bit later, how we actually do that. Then we have the service agreements here. We have people verifying, or agents verifying that the service actually behaved well. And then on top we have more like the discovery, the opinion, and the curation part of things. So we say, well, our lowest layer where the smart contracts are running is the keepers. Then we have verifiers who verify bespoke services. On top of that, we have curators that are more into the opinion and signaling game. Another way to look at the same thing is the components, the microservices you're going to deploy. We have metadata discovery functions. Here we use technologies like BigChainDB or more centralized database technologies to set up marketplaces. And just like catalogs and discovery of those services actually. These agreements are running onto currently Parity POA. But they're just EVM compliant. They can also run on Ethereum mainnet, and that's what they do. And then the verifiers, this is bespoke cryptographic nodes. So we have one thing that we're using from Parity as well here is called secret store, and that's a way to basically shard of secret into little pieces and then have things like threshold encryption and threshold decryption, and it's very interesting for us to use. On the consumer side, we just have wallets. We have things like burner wallets as well to make the onboarding quicker. We have plugins with existing tools like data scientists. They love to use notebooks in Python, so we made dedicated plugins there so you don't really have to go out of your trusted environment. On the other side, we have, well, Web 2 real estate, meaning cloud service like Azure and AWS, and those need to kind of hook into the smart contract layer, right? So here you're looking at Web 2 authorization and authentication, and now you have to find a way to drive that access policy with our decentralized access policy. So for this, we have like kind of a proxy node that you would run in your cloud, and that proxy node makes all the bridging with our decentralized access policy possible. This is kind of how our engineers designed it. The interaction flow between all these things. So you have your decentralized access policy, you have your centralized access policy on the cloud. This node will basically make sure that those two are respected. We have a way to share secrets for example, session keys throughout the secret store, which allows us to encrypt and decrypt in a decentralized fashion. And then we have this OceanDB, this discovery service. So you have to hop up, like this is basically saying that how the protocol looks like. You start with posting your service into the metadata. Someone can discover and find it, then tries to negotiate access. The access points, hey, you kind of want to follow this smart contracts, and that will dictate what you actually have to do. Maybe you want to deposit some tokens. Maybe if you're permitted through your public key that you're part of a tribe that nurtures the commons, then you automatically get access to more set of services because you're a commons provider, then you automatically become a commons consumer, and et cetera, et cetera. The details are in the code, of course. So what was required, and maybe I just want to have a little time check here. All right, 7 minutes. Contract deployment and development. So we could easily identify these type of smart contracts were necessary to deploy this. The pink ones, they popped up as we went along. So we factored this in, and this was kind of, oh yeah, damn, oh, we need to put something here and there. And that basically, that hurts your deployment timeline, right? So if you know this up front, well, if you have a token, you also want to have some roles for the token to be dispensed into the network. So you need to create contracts that can either be a placeholder for that role, or they actually have capabilities to mint and burn tokens inside of your system. But you have to account for it. If you want to do some side channels, or you want to have a side POA, then you need to have something like a token bridge that can communicate back and forth with another chain. So you need to set that up as well. It also has additional services attached to it. And then if you run a POA network as we do to make stuff more smooth, then you need to govern the network nodes inside of this POA network. And it's also, you need to have the ability to add nodes, remove nodes, add permissions, remove permissions, all these things. And then there's a set of utility libraries that's very practical to maintain, allows you to upgrade quickly. So from a topology point of view, we started them fleshing out, well, we know what the capabilities are, we kind of identified what the contracts are, now we need to find out what's the permission structure and the roles we need to deploy in this system. And sometimes we didn't know up front who was going to be that role, so then we either had to set like a temporary role managed by the foundation or organization. In our case, that's the Ocean Protocol Foundation that then says, well, in the future we're going to assign this role to a dedicated actor in the system, but now we don't know yet, so we'll put the Ocean Protocol Foundation as a stub in place. So as you can see, we identified a lot of roles here and made sure that, well, all of these things can be connected. More importantly, you want to look at how the timeline for your deployment. These things have to go in lockstep. Like you deploy one thing, then you have to deploy the other thing. And for example, you need to have your wallets first to deploy the token contracts. You need the token contracts before you do the dispensers. Then you can start registering the token minters. And then the stuff that we actually thought the only thing we had to do. So that's then saying that, well, we need to have a registry for all the services. We need to have the service agreements, and then the administration functions, etc. So we went through all of these things, and actually what we did is we also created an open source tool, because this a lot of, well, there's things like Zeppelin OS and it's super useful, but you're gonna have to do a lot of the custom tooling. So we put our custom tooling and our learnings into a repo called Ocean Protocol/Dori, D-O-R-I. So you can see how we did it. There's a lot of interesting scripts that help you deploy these things, set roles and administration functions inside of our network, and that probably also translates to other networks. Last but not least, what we figured, and that's a tough one, always upgradeability in smart contracts, right? Because you deploy it kind of sticks there, and there's a lot of, if you want to change something, it will affect a lot of users and wallets and things like that. So you need to proxy these things, and you need to make sure that, well, if you change the logic, you don't change the memory layout that's currently existing in your smart contracts, because you have to make things backward compatible. If you start fiddling with the memory layout inside of your smart contracts, you're gonna hit problems for sure. So our logical separation is storage and logic separate proxies for that. So that's kind of the practical things. Some takeaways we had. Token engineering, however you call it, you need to have a solid production plan in order to put this in place. Think about upgrades and governance up front, not too hard, but do follow some guidelines and have a look in our Dori repo where we'll be adding guidelines as well. And yeah, you'll be facing a lot of bespoke tool change, but your DevOps hopefully know how to work their way around this. Yeah, that's kind of it for my talk. Do we do questions or?
We might have one question. Any question on Dimi's talk? Yes. Do we have a microphone? Yeah.
Yes, can you tell us some major clients that are using your Ocean protocol?
Using or engaging, because currently I don't think we have production users yet, as we launched our public network 2 months ago. But we're engaging with the Singapore government. We have in Singapore some auto registry set up. We are also working with the MOBI consortium. We have a few dedicated projects with some automotive companies. We have a company in Munich, Connected Life, looking at the healthcare capabilities of Ocean Protocol. They're looking at chronic diseases like Parkinson. I'm not responsible for the business pipeline, but one of my colleagues actually knows a little bit more and is hiding. So Don, show yourself. There is Don. So definitely have a chat with Don. He knows a bit more about the funnel.
Okay. Thank you, Dimi, for this talk. Thanks a lot.
My pleasure.
Thanks.